When we look up at the night sky, it doesn't seem to change from night to night. We like to believe that the heavens are constant, the stars have set luminosities. There's a class of stars, however, that challenge this belief. They are called variable stars. As the name suggests, variable stars are stars that can change their brightness. There are two main types of variable stars, extrinsic and intrinsic. Both of these branch out into many different possible types. Today, we will be focusing on the pulsating variable type. Pulsating stars are a subtype of intrinsic variable stars. This means that their mechanism that causes their oscillation happens within the star, but there are a few exceptions. Their brightness changes due to the star periodically increasing and decreasing in size, and some of these periods are extremely predictable. Some common types include classic Cepheids, type 2 Cepheids, Aurora Lyrae, Mira, long period red giants, A Cygnus, and Delta Scuti stars. This is a diagram of where pulsating variable stars can be found on the HR diagram. There are many types of pulsating variable stars, and they can be found all over this diagram. One interesting phenomenon is the Blasco effect observed in Aurora Lyrae stars. It is a variation in period and amplitude that occurs over time. It was first observed in 1907, but scientists are still trying to determine what causes it to this day. One possible factor is the period doubling phenomenon caused by Aurora Lyrae stars having 12-hour pulsation periods. Because nightly observations are made 24 hours apart, the maximums observed at night differ from those observed in the day, as shown by this light curve. The Blasco effect is most likely due to nonlinear resonance between different oscillation modes. Scientists have also hypothesized that magnetic fields and convection cycles may also play a role. However, the physics behind this phenomenon has not been fully worked out. In the future, scientists hope to use data from the TESS and Plato missions, as well as spectroscopic observations and computer models to determine the cause. Recent studies from the past few years have discovered 4 new types of pulsating variable stars. The 2 most interesting of the 4 types are binary evolution pulsators and heartbeat variables. Binary evolution pulsators are low-mass stars, but they mimic Aurora Lyrae stars and are even known as Aurora Lyrae imposters. Heartbeat variables occur in binary systems where eccentric orbits and tidal forces excite a low-amplitude pulsation in one of the stars. Recent observations have also revealed special cases of rapid stellar evolution among variable stars, and the Blasco effect has been observed in classical Cepheids. I'd like to end this video with a demonstration of pulsating variable stars. Observe the difference in brightness between the bigger balloon on the left and the smaller balloon on the right. Although it's not a perfect analogy, pulsating variable stars are essentially just big balloons.